Good evening, everyone. This is Unit 1 AS Physics. The topic-wise discussion the question related to SI quantities, graph, and motion. In the last session, I discussed first 20 questions, and we'll continue the discussion from 20 onwards. This question, Saturn V rocket used in NASA space program had a mass of 3.04 into 10 power 6 kilogram. It took off vertically with a thrust of 3.4 into 10 power 7 Newton. Show that the resultant force. So how to get the resultant force? For example, if this was a rocket, the weight of the rocket is acting downward and the thrust will act upward, and the difference of the two will give us the resultant force. So resultant will be equal to T minus W. So mass is given. First we have to convert this mass into weight. We have the formula W is equals to mg. So you can write weight is equals to mass multiplied by gravity. The mass was 3.04 into 10 power 6 multiplied by gravity is 9.81. So this will give us 2.98 into 10 power 7. Now to get the resultant force, because the resultant force is a thrust minus the weight. Thrust was 3.4 into 10 power 7 minus the weight is 2.98 into 10 power 7. So the difference will be 4.2 into 10 power 6 Newton, which is a resultant force on this rocket. Calculate the initial acceleration. So we have the formula F is equals to ma. And what we substitute here, we substitute a resultant force. So resultant force is 4.2 into 10 power 6. So the resultant force is 4.2 into 10 power 6. The mass is 3.04 into 10 power 6, and acceleration we are finding. So 4.2 exponent 6 divided by 3.04 exponent 6, we get the initial acceleration, which is 1.38 meter per second square. The next part, after 150 seconds, the rocket reached a speed of 2,390 meter per second. What is the average acceleration? So we have the time interval, and we know the speed. So we can use the equation of the motion. This is a final speed. So acceleration is v minus u over t. The final speed is given 2,390 minus the initial speed is 0 divided by the time interval, which is 150. So we'll get its acceleration as 15.9 meter per second square. So initial acceleration and the average acceleration are different. The initial acceleration, when we calculated, it was 1.38, but the average acceleration is much higher, which is 15.9 meter per second square. Suggests why the initial acceleration and average acceleration are different. So what is the reason why they are different? Because this rocket is burning the fuel, so its weight, its mass will change, so the weight will also change. So resultant force, because resultant force is a thrust minus weight, so weight is changing continuously or weight is decreasing. So if weight is decreasing, what happens? The difference will be higher, so resultant force will increase. So mass is continuously decreasing. Because of mass, the resultant force, the weight will also decrease, which increase the resultant force. Moving on to the next question, question 22. You're asked to determine the acceleration of a free fall at a surface of Earth G using a free fall method in the lab. Describe the operators you would use and measurement you would take, and how would you use this to get the value of G. So there are different ways to find this acceleration due to gravity. We can use light gauge, we can use electromagnet as well, an electromagnet. So, or if we are using a light gauge, like example, a cylindrical tube is there, an object being dropped, and we place a light gauge at the bottom. We'll measure the height by using a meter rule or a meter scale. We'll measure this height h, and we'll measure the length of this object, because length divided by time will give us the speed. How will know the time? The time interval it will take to interrupt the light gate, that is the time interval, and length divided by time will get the speed at this point. And what is the appropriate equation according to this? This is a procedure, like this apparatus. Initial speed is 0, so we have this formula 2as is equals to v square minus u square. So 2gh is equals to v square, because the initial velocity is 0, or we can also say v square is equals to 2g. And so if we draw a graph on y-axis, if we have v square, on x-axis we have the height, the gradient will give us 2g, or g will be equal to gradient divided by 2. So this is a procedure to calculate, to find the acceleration due to gravity of an object falling freely on the surface of Earth. Give one precaution you would take to ensure that the accuracy of the measurement. So according to the procedure, because what we'll do, we will avoid a parallax error when measuring the length, and we will make sure that object does not reach terminal velocity. Moving on to the next question, question 23. Acceleration can be found from, so how we can find acceleration? If we have a speed time or a velocity time graph, basically the gradient of the velocity time graph, the slope of the velocity time graph will give us acceleration. So area under the graph, that's wrong. Area under the graph for velocity time graph will give us a distance traveled. The gradient of distance time graph will give us a velocity, and gradient of a velocity time graph will give us acceleration of an object. In question 24, which table is correct for scalar and vector quantities? So scalar quantities, they have magnitude but no direction, whereas vector quantity, they have magnitude as well as direction. So scalar has magnitude, vector has magnitude, that's right. And scalar does not have direction and vector is having a direction. So option C is the right answer. Which of the following is not a unit of energy? So when we write the formula for energy can be kinetic energy, potential energy, or work done. That is force multiplied by distance. So unit of force is Newton, unit of distance is meter. So Newton meter is a unit of energy. What about kilowatt hour? How we get this answer? We know power is energy divided by time, so power multiplied by time will be equal to energy. So power can be in watt or kilowatt and time can be in hour, so kilowatt hour is also unit of energy. What about watt second? If power is in watt and time is in seconds, so watt second is also a unit of energy. But we don't find Newton per second, so Newton per second is not the unit for energy. A body is acted on by a vertical force of 18 Newton and a horizontal force of 32 Newton. The angle to the horizontal, the angle to the horizontal of the resultant force. So we have a body which is horizontal force is 18 Newton and the vertical force is 32 Newton. So the resultant is from tail of the first to the head of the last. That will be the resultant. So this one is a resultant. Now we need this angle with the horizontal. So if we need the angle, we have the perpendicular because this one is a perpendicular, and we have the base. So we can use tan theta. The tangent theta is equal to perpendicular divided by base. The perpendicular here is 32 and the base is 18. So tan theta is equal to 32 divided by 18, or theta, we need an angle that's equal to tan inverse 32 divided by 18. So tan inverse 32 divided by 18, so D is the right answer. The next, the magnitude of the resultant, because using a Pythagoras theorem, we know hypotenuse square is equal to base square plus perpendicular square. The hypotenuse is unknown. The base here is 18 square plus perpendicular is 32, and we need resultant here, so it will be under root 18 square plus 32 square. So under root 18 square plus 32 square, so D is the right answer for question 27 as well. Here in this one, the horizontal force is 32 and the vertical is 18. So I should change because I thought it was written other way around. So this should be 18 and 32. So the answer according to this will be 18 and 32, or it will be tan inverse 18 divided by 32. So it will not be D, it should be B. Because I thought in the first forces, the vertical, horizontal one instead of vertical. In question 28, a ball is dropped from rest from a building which is 35-meter high. So the distance is given. And if air resistance is neglected, the ball hits the ground with a speed. So if air resistance is neglected, it will have an acceleration due to gravity and it drops from rest. So initial velocity will be 0. We need the final speed. So we'll use the formula 2as is equals to v square minus u square. So 2 acceleration is due to gravity 9.8. The height, the distance, that is 35. V square minus initial speed is 0, so 0 square. So it will be 2 multiplied by 9.8 multiplied by 35 and under root. We'll get this V. So after solving, it will come out as 26.2. So D is the right answer. Which of the following is a vector quantity? Distance is a scalar, force is a vector, speed is a scalar, work done is a scalar. So B is the right answer. Which of the following quantities is scalar quantity? Displacement is a vector, force is a vector, time is scalar, velocity is vector. So C is the right answer. And question 31, a bus is traveling at a speed 9 meter per second, so that's U. The acceleration is 0.75, so that's A. And it accelerates for 8 seconds, so that's T. So we need V. So we have the formula V is equals to U plus AT. The initial speed, that is 9, acceleration is 0.75 multiplied by 8. So for question 31, 9 plus 0.75 multiplied by 8, it will come out as 15 meter per second. Which of the following is not a SI base quantity? So force is a derived quantity, that is a base quantity. This one is a base quantity and a base or fundamental quantity. So A is a right answer for question 32. In question 33, the diagram shows the forces acting on a pitcher of weight W suspended by a cord. The tension in the cord is T. Which of the following expression shows a relation between weight and T? So T will have its component, the one which is with an angle, this will be T cos theta, and once which is against the angle, that will be T sin theta. Same thing for the other one, that will be T cos theta, and the upward will be T sin theta. So T sin theta is acting upward for both. This is T sin theta, this one is also T sin theta, and weight is acting downward. So we can say 2T sin theta balances with the weight. So 2T sin theta balances with the weight. So for question 33, D will be the right answer. The next question, the photograph shows a sequence of images of a bouncing tennis ball. A student plot a graph and claim that it shows a vertical motion of a ball. So the graph is shown. For a velocity time graph, the slope represents acceleration. Slope or gradient represent acceleration. So you can clearly see that the acceleration, because if acceleration is same, the gradient should be same, the angle with the x-axis should be same. But you can see the graph, like example, if I label this line as AB and x and z, you find they're not parallel. If they're not parallel, means they have different gradients. So without carrying out any calculation, describe how the following can be found from the graph. The vertical distance traveled by the ball from 0.5 to 1 second. So how we can find the vertical distance from 0.5 to 1 second for a velocity time graph? So we can find the area under the graph for between x and y. The acceleration at y, so how we can work out the acceleration at point y? So we'll find the gradient between x and y. So by finding the gradient of line x and y, we'll get the acceleration at y. The graph contains several errors, and in its representation of a motion explain two of these errors. So first thing, an object is dropped. Whenever object is dropped from certain height, the initial velocity is zero. But here, the initial velocity is not zero; it is starting from certain value. So that is one mistake. The second thing, the gradients are not same because acceleration is due to gravity when we ignore the air resistance. So acceleration is not same as the gradient of the lines are not same. So the two errors are, one, the graph is starting with a certain velocity, and the second one, the gradients are not. So lines are not parallel, we can mention that. which shows different acceleration for falling object, and the initial velocity is not zero. That is the second arrow. 35. Which statement about the scalar and vector quantities is correct? Scalar have direction only. Vectors have magnitude and direction. Magnitude and direction. Vectors have magnitude and distance. So scalar does not have direction. Scalar have, that's not correct. Vector have magnitude and direction. So C is the right answer. Magnitude and direction. Here magnitude and distance. So that's wrong. Which of the following is equivalent to Pascal? So Pascal is a unit of pressure which is force acting on unit area. The unit of the force is Newton and unit of area is meter square. Newton, in the base unit it is kilogram meter per second square, and that is divided by meter square. So when we simplify this, it will turn out to be kilogram second square meter, or we can say kilogram second minus 2, or meter minus 1, or meter minus 1 second minus 2. So C is the right answer. A model boat is crossing a stream. The stream is traveling east. So we have the directions, the campus, north, south, east, west. So stream is traveling east at a speed of 1.5 meter per second. So that's 1.5 meter per second. And the boat is heading north. So boat is heading north with a speed of 0.5. The magnitude of the resultant. So when we find the resultant from tail of the first to the head of the last, so that will be the resultant. So base here is 1.5 and perpendicular is 0.5. So according to Pythagoras theorem, the resultant will be equal to 1.5 square plus 0.5 square in under root. So 1.5 square plus 0.5 square in under root. So D is the right answer. The next part, the next question basically, which of the following is a unit equivalent to Pascal? So it's a repeated question. C is the right answer. Which of the following is a derived SI unit? Joule is a derived unit. Meter is a base unit. Power is the derived quantity, not the unit. And time is a base quantity, it's not a unit. So we are finding derived SI unit, so that's Joule, which is a unit of energy or work done. Question 40, a student is asked to solve the problem. An object is thrown upward with a speed of 25 meter per second, so we know u. How it will be when the speed is 12, so we know v. Which equation will allow the problem to solve in a single calculation? So when object is thrown upward, its acceleration or deceleration will be according to the gravity, which is minus 9.8. So for question 40, because we have v, we have u, we have a, so we can use it to find. Because the other equation involve a time, and the time is not given in the question. In question 41, that's second last question. In this experiment, student releases a small steel ball in front of a meter rule and uses a video camera to record the motion. The camera captures 30 images per second. So every Second, it captures 30. How acceleration of a free fall can be determined by using this technique. So what student did, he used a meter rule, place a meter rule, he dropped an object and he record the motion of this object by using a video camera. So how we can use this method? To work out the acceleration due to gravity. So we will measure the position on the rule for each frame. That will give us the distance. Then we will find the time between the frames. So we have the distance and we have the time interval. So we can use this equation to as is equals to, or we can use s is equals to ut plus half ut square because we don't know the final speed. So s is equals to ut plus half ut square. Initial velocity is 0. So if you use 0, it will turn out to be s is equals to 1 by 2 gt square. Acceleration is due to gravity. Then if we compare with the equation of straight line, y is equals to mx. So on y-axis, if we have a distance, on x-axis, if we have the time square, our gradient will be equal to g by 2. So gradient will be equal to g by 2, or the acceleration due to gravity is gradient multiplied by q. Describe a systematic error which could arise. So systematic error in this, the time interval which we are recording here, like example, when we are dropping an object, we consider that is our first image, but maybe at the position of first image, the initial velocity might not be 0, or the meter rule might not be vertical, or camera is not aligned. These are the systematic errors. Sorry. At the first image which we captured, so these might be the systematic error which leads to the wrong values of acceleration due to gravity. Describe one property of a steel ball that makes it suitable to use in this experiment and how this property make it suitable. So why we are using a steel ball? Basically, it's a dense material, so it will not reach terminal velocity easily. And because it's a sphere, so it will have a streamline. It's a streamline object, dense object. It does not reach terminal velocity because to reach a terminal velocity, resultant for the weight minus air resistance should be 0. The resultant should be 0, but because the weight is a dense object, so weight is greater, so it need a greater air resistance, which is compared to other object, which is smaller air resistance as it is a streamline object. Explain an advantage of using a video camera to take measurement for this experiment rather than using a stopwatch. So what are the advantages? There's no reaction time, because so if there's no reaction time here, it reduces the uncertainty, and it can be pause and replay or playback, so we can check the values or repetition is done or more accurate values are there. So no reaction time, which will reduce uncertainty, and can be repeated or playback to increase to improve the accuracy of the experiment. Question 42: which of the following is a correct statement? Weight is a base quantity. It's not a base quantity, it's a derived quantity. Velocity is a base quantity. No, it's a derived quantity. Mass is a derived quantity. No, mass is a base quantity. And force is a derived quantity. So D is the right answer. Explain the advantages of using a digital video camera compared to a rule and a stopwatch to obtain the data of acceleration due to gravity. So we already discussed this. I will quickly go through this part, that it reduces the uncertainty in the measurement as more precise results are there. There is no reaction time. So error due to the reaction time is reduced, and it can be paused and playback again. So these are some. So no reaction time, can be paused and playback, and can take a reading from every frame or more readings are there in a given time. Allow use to be checked, values to be checked, and you can zoom in as well. So these are the topic-wise questions from Unit 1, SI quantities, graphs, and motion.